Okay. 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 We should be live, actually. Could you confirm you can hear me? Okay, we are online. One second, please. I need to check one last thing. Okay. Okay. We should be live, actually. Could you confirm you can hear me? Okay, we are online. It's 34th. Okay, you want to do the
One
intro?
second, please. I need
Okay.
to check one last thing.
Okay. Okay. Put it here. Okay. Hello everyone.
We should be live,
And
actually.
it's kind of
Could
strange.
you confirm
We
you can
designed it so
hear
we
me?
can cite on the site and maybe look at.
Okay, we
This
are
is the
online.
important
It's
information from the stream, and
34th.
here is less important information.
You want to?
The speaker.
One second, please. I need
okay.
to check one last
Hello everyone. On the 34th, I believe,
Okay.
Rust Meetup.
Okay.
We are probably the
Okay.
longer
We
living
should be live,
Rust
actually.
Meetup.
Important
It's kind of strange.
confirm
We
you can
designed it so
you
we
have
can cite
long
on the site
history of
and maybe look
every
at.
month
Okay.
talking about Rust.
We are
This is the
online.
important
Do you?
information from
Even
even
while
while there
we
is less
had a
important
pandemic,
information.
we
You want to?
tried to organize
the
some
speaker.
One second, please.
online
I
meetings,
need
and
to check one last
today
Everyone on the
we are organizing
34th, I
the
believe,
last
Rust Meetup
meeting
Okay.
before the
we
holiday
are
break.
Probably
But
the
don't
longer
worry,
living
we will
Rust
come back
Meetup.
to you.
It's kind of
you
strange.
confirm you can
Designed it so
you
we
have-
can
We will come
long
back to
history
you
of
every month
Okay.
talking about Rust.
This
After
is
a
line.
vacation break,
even
probably
while there is
October
less
or
important
pandemic,
information.
we
You want to?
tried to organize the
One
speaker.
second,
Today we
please.
have
I
meetings
need
and
to
talk.
check one last
Today
Everyone
on
on
the
the
we are
34th,
organizing
I
the
believe,
last
Rust
meeting
Meetup
before the
we
holiday
are
break.
Probably
But
the
don't
okay.
worry,
Basil,
we will come back to you.
Okay,
so Basil will
designed it so
go
we
have
can
we will come
long
back to
history
you
of
with every month
Okay.
talking about Rust.
This
After
is
a
line.
vacation break,
even
probably
while there is less
about
important
pandemic,
information.
the web assembly, how to write
Rust.
today
Web
we
assembly.
have meetings and
Okay.
talk.
Okay.
Today on the
we
34th
organizing
web
the
assembly
last
Rust
meetup
before the
we
holiday
are
break.
probably
But
the
don't
okay.
worry, it
Basil,
will be
Basil,
good living. We will
Basil,
come
Basil,
back to you.
Okay, so
before that,
designed it so we can
we will come back to you with every month
Okay.
tell that about Rust.
This
After
is
a
line.
vacation break,
even
probably
while there is
not
less
about
important
pandemic,
information.
the web assembly, how to write that. Today we have meetings and talk. Today on the 34th web assembly Rust meetup before the holiday break.
Our best,
But
don't
don't worry, it will be
good
good living. We will come back to you.
Okay, so
before that,
designed it so we can
we will come back to you with every month tell that after a vacation break, even not about pandemic, the web assembly, how to write that. Today we have meetings and talk. Today on the 34th web assembly Rust meetup late holiday break.
our best,
But
don't
don't worry, it will be good living. We will come back to you.
Okay, so
before that, we need your help. We will come back to you with every month tell that after a vacation break, even not about pandemic, the web assembly, how to write that. Today we have meetings and talk. Today on the 34th web assembly Rust meetup late holiday break. Our best, but don't worry, it will be good living. We will come back to you.
Okay, so
before that, we need your help. We will come back to you. Nice idea. I know tell that vacation break, even not about pandemic, the web assembly, how to write that. Today we have meetings and talk. Today on the 34th web assembly Rust meetup late holiday break. Our best, but don't worry, it will be good living. We will come back to you. Okay, so before that, we need your help. We will come back to you. Nice idea. I know tell that vacation break, even not about pandemic, the web assembly, how to write that. Today we have meetings and talk. Today on the 34th web we cannot play. I'm sorry. I mean, I'm not talking about you. I mean, I am. We had some late we cannot play. I'm I mean, I'm not talking about you. I mean, I am. Okay, maybe someone from stream could confirm if this is better right now, because actually 2 channels were. Okay, is it better, Patrick, or is it doubled still?
It's still playing from the past, so a second. It was really doubled. It was like, yeah.
It's better.
We're good. Yeah.
Great. So please, great shout out for Basil and.
Can I plug in?
Okay, you want to plug in your hardware, but now I will probably lose it on the stream. So wait a second. I need to.
Don't worry, we'll take a minute. Click and click.
Okay, it seems to be working.
Should it be? Right. WebAssembly, hot topic. It has been conceived for a while, but it seems that it's mainly used outside of a browser for some reasons. Ooh, what is that? Okay. Okay, good. So what I want to talk to you today is WebAssembly, how it's been conceived, and state of the work that we've currently got in the Rust environment. So the talk will be as follows. We'll start with a bit of a brief history, how the in-browser programming actually has been conceived and how it works. And more about tooling available for us Rustaceans when it comes for WebAssembly programming. We'll do some examples in a couple of common and best known libraries for that. We'll do performance comparisons, how well WebAssembly actually is performing against JavaScript. And we'll talk a bit about the future that WebAssembly has, especially in the Rust environment. Okay, so starting from the very beginning, to answer the question what WebAssembly is, we need to have a small history of dynamic websites. Apparently somewhere around 96, ECMA, as a foundation, has started specifying a standard called ECMA 262. The strange number over there is mainly because there was already something like 3 different standards of JavaScript back then, and none of them were actually working well. And it actually has been specified by these guys first, and it even took them 4 years before they will be able to define and implement the way you can change the site's DOM structure from a JavaScript code. Obviously, because of the speed performance problems that it actually had, all of the browsers implemented JIT compilation. I suppose that I don't need to explain exactly what the JIT compilation is. Well, pretty much all of them has done that. Obviously, Microsoft was a bit late of this, but even with all this stuff in, it was still very slow. So there happened to be a couple of very brainy guys at Mozilla Foundation back then, and they came up with an idea. They call it ASM.js. ASM.js, and this is taken pretty much from their own old website, is a subset of JavaScript that is allowing non-JavaScript applications to be run as web applications. And that should perform better than the JavaScript alone. Obviously, the duplication of the word JavaScript over there in completely two different sides very quickly can tell you that that was not really true. But it was important from a completely different perspective. People wanted to have applications already written, deployed on their websites, including games. I think Doom was one of the first that was deployed using this awesome.js. So what actually did it do? Well, the subset word is actually not really fully fit in this equation because it was doing actually a bit more with the JavaScript itself to allow these applications to be transpiled rather than compiled into the awesome.js. Let's take an example. What they did with numbers. This is a part of a JavaScript code that actually simply adds a number. It increments a number by 1. And as simple as it seems to be over there, for interpreter's perspective, it's not that simple at all. It was still interpreter language. So if you had, for example, a real C++ code or CC code that was being transpiled to it, what it actually needed to do is OR every single number with a 0. And as stupid as it sounds, because it shouldn't be doing anything with a number, for the interpreter of JavaScript, it did a lot. Mainly because JavaScript itself always had a floating point number as any number in the system. Even if you wrote yourself a 10 as a value, it was always used as a floating point number. But if you OR it with a 0, so you pretty much masked it with a 0, it understood that it's not really a floating point number, but a standard integer. And that helped with all the maths that was being done with the interpreter behind it. With all of these things, they were able to really transpile a lot of applications into it. I think even Unity engine was transpiled into this awesome.js stuff. But obviously, conclusion out of it is quite simple. First of all, it's not really a subset of a language. It's a superset. And it was adding a lot of additional boilerplate to build up applications that can be very small if it's being done, an example, in CC or Rust. Back in the day, there was no Rust back then, but it could be. And that means that translating an CC code into the awesome.js was pretty much an overkill. Also, these numbers optimizations that were core of the whole system was not really a good idea. It was worrying most of the people. That's why awesome.js was killed in 2017 because they've introduced a WebAssembly. They already had the JIT compilation of everything that was done in the browser. Every JavaScript was already compiled into the native semi-binary thing that browser can simply run. So if we've already got that, we can standardize it, right? And this is exactly what they did. 2017 is a beginning of the WebAssembly usage in the browsers because this is actually the year when all major browsers implemented it as a standard. This standard obviously evolves up until this day, but it has most of the stuff that we need to develop anything that you want to have in the WebAssembly. So let's get back to our environment, Rust. So Rust already delivers. Rust doesn't deliver anything. The people that develop Rust has already delivered numerous of different frameworks that allow you to deploy web applications. One of the most well-known one right now is Vue. Probably most of you have already heard of them. We have Leptos, which is another quite known right now, although it's being developed by a single guy right now, Greg Johnson. There's Dioxys, but actually a predecessor of Leptos. There's Tori, and even something called Iced, which is a completely different approach because it actually is using WebGL to render anything, and it can render GL stuff, different outputs. One of them is actually web. So we're not talking about these. We're talking more about this more standard way of computing and making websites. So we'll stick to the first two, I think. This is the best guess for this talk. So let's start with how to set up quickly a toolchain to do it. First of all, you need to have a target. which is a WebAssembly target installed with your Rust environment, you need an additional tool called trunk that will be helping you out with compilation, transpilation, and preparation of all boilerplate parts of a system that you will be then calling your sort of website, such as index HTML page plus some boilerplate small JavaScript code in which it will be setting up all the WebAssembly parts. Plus, this is actually the tool that will start you the web server on your local computer, so we can actually check out if everything works exactly as it should be, and that's pretty much it. You can simply create an app, and that's it. First of all, obviously, when we're talking about you need to have it configured to use you as the dependency. Obviously, the feature CSR means that we will be doing a client-side rendering over there. And it's only a part of the features, right? So all of the Rust libraries also deliver server-side rendering. So it can act on both server-side and client-side, but we'll stick with the client-side only right now, because this is what this talk is really about. I'm not really fond of solutions like this hybrid solutions of CSR and SSR, but, well, potato, potato. Index HTML that you'll have to include with this is pretty much very straightforward. You don't need to put anything over there. It's just a simple head, an HTML tag, that's it. And there's also, well, your app. To start it up, you just need to call simple urenders machine, and that actually starts up a rendering of the first main component called an app. Because as most of the already existing JavaScript parts, U is pretty much very heavily copying this, the way of making websites from React, at least from a code perspective. So everything's being component-based. You have to have the first component. Let's make it happen. Here we go. That's a simple code that actually makes something work. So what it does over here, first of all, this is a function component. U also allows you to create the structure components. I'm super fond of making a functional ones, so this is why the example is function one. It creates a function component called an app with a capital A. And the function only needs to produce an HTML result. And that can be automated very heavily. You can see on the bottom, they have the HTML macro that actually does it for you. Very familiar to all of the other frameworks that you might know if you will be doing any JavaScript back in the day. And that's it. You're creating a state in which you'll be having a number, default's 0, that's why the 0 over there in a use state function. Then you're creating, well, event on click that is taking that state, adding a 1 to it, and sets it back. And that will automatically re-render the component. And that's it. To run it, you're just running trunk serve, and voila, that's simple. Obviously, it's not that you have just one component and that's just exactly how your application will look like. You will have different components. So let's create one just for starters and for kicks. A button component. A button component that will have properties. So we need to create a special struct that will be deriving from properties. Over there you can create different attributes that you want to pass on to component of your own. And then just create yet another component with the same style. In here you can see that it's simply taking the props and then producing the HTML structure using HTML macro. Quite simple as for now. And very straightforward. To use it, well, it's that simple. You're using it inside and you're just passing on all the attributes or properties that you had before. What you might notice though is that none of these components you've seen so far is able to take values as, let's say, children. It's not entirely true. You can put something inside of your own code, or inside of your own component, but it always will be yet another children's components. You're making context this way. So if you want to have some kind of a global context of different attributes or whatever, this is how you do it. But until now, the only way to pass attributes is only by the attributes inside of a tag. U is already working with this to expand it, but there's still a long way to go. But hey, congratulations, you just create your own app and you can easily extend it. It actually works, it's very quick to do. What about debugging? Right, most of the browsers already give you great developer tools over there that you can simply use and debug your applications in. But this is a native app. It's not a JavaScript that browser can simply load and give you a breakpoint for, and you can just stop over there without running. It's binary, right? Well, typical Rust app can produce a dwarf files with symbols of something that you're compiling. But Trunk right now actually forgets to make them. Also, only Chrome and only latest Chrome right now supports dwarf formats. Not that it was impossible back like a year ago. It was possible with some external tools, but it was always very difficult. And up to this day, we don't have an automatic mechanism to make all of this work. So even though we have numerous of different frameworks to develop web apps using WebAssembly with Rust, debugging is mostly console logs, which is not the greatest way of doing it. Obviously, if you dig well enough, you will find a way how you can actually attach the dwarf file that you will produce to the browser. It's extra couple of clicks, and then you can actually make a breakpoint and it will stop at this breakpoint occasionally, not always. So it's still a long way before we'll see a real debugging. But okay, debugging aside, that means that this is a super fast solution because it's native, right? This is why we're doing it, for safety and speed. This is why we're doing it on WebAssembly instead of a JavaScript. So there's a very nice framework available to everyone that builds up statistics of all frameworks benchmarks. It's benchmarking them itself. Every single framework delivers a simplified version of a special website using this particular framework that has different actions you can move over there. Actions like creating 1,000 rows, or update some rows, or swap some rows inside, or create more even rows, right? There's something like, I don't know, a couple of hundreds different actions that you can do over there. It's been run, you can run it yourself on your own machine, but it's being run by these guys themselves, and they're producing occasionally they're producing comparison of all frameworks available over there. So let's compare something. Let's compare React to Vue. Okay, so let's quickly compare the numbers. Numbers are not in real seconds or milliseconds because it's really obsolete. Different browsers, different computers will give you different time results. What they did, they've compared them side by side. So the quickest framework in each category gives 1.0 speed. Everything above it is pretty much a comparison of the speed of the fastest ones to all the others. So React, when it comes for creation of 1,000 rows, is 1.34 speed of the fastest creation of 1,000 rows. And update is something like 146. And swap rows is 661, quite big one, which is kind of interesting. And creating a big chunk of rows is 1.66. So how's Vue in that comparison? Well, not good. So creating 1,000 rows is actually slower than typical React, which is a very heavy library. But when it comes for updates or swaps, it's way better, especially with swaps. When it comes for creation of more rows, it's even worse. But why? Why? To answer that, we need to answer more burning question, which is how WebAssembly actually works. Let's take a simple macro from the Vue library. It creates one div with one paragraph with a simple text. So In Rust code, it will look something like this. It's a simplified version of it, but with all the unwraps that shouldn't be there, it doesn't really matter right now. But what it does, it's using a special websys crate, it takes out the window, document of the body, body's important over there, then it creates div element, creates p element, sets a text content, and append all the children to its place. Okay, so I want you to look closely at one particular line. It looks extremely similar to the camel-cased version of it that you've probably seen quite often because it's actually a JavaScript call. WebAssembly cannot change DOM on its own. WebAssembly, until this very day, is unable to do anything outside of its own sandbox. To interact with browsers, you need to interact with JavaScript calls that browsers actually implements. And that's not a good idea. Why? First of all, WebAssembly, Rust in particular in here, uses UTF-8 for any string inside of it. JavaScript uses UTF-16. Whenever you're doing a call across the border from one to the other, you need to use a WASM bind gen bridge to all DOMs, and that means that you need to do a copy and conversion of every single string from UTF-8 to 16 and back if you're doing some readouts back. And remember that both of them are still single-threaded. Well, that means that more strings you're pushing through the border, slower it gets. And that's not it. That's not all, really, because also size do matter here. Because let's take the testing React application size. It's actually 280 kilobytes, more or less. U version weighs 347 kilobytes. And just for kicks, I took the number of pure JS application, which is what 150 kilobytes. And remember that you can chunk JavaScript applications. You can put all of them into different files. You can't, however, do it with a Rust app. It's always a single binary. So what can we do to make the WebAssembly application faster? Well, there are some speed hacks, and let's talk about a few of them. First of all, you can cache all commonly used strings. Whenever you're creating tags or you're adding attributes, they're quite common, right? P, div, all of that, you can cache it. You can cache it on both sides, so you can actually create already bridged strings on both sides. You don't copy them from one to the other. You're using integers as enums or whatever, just to pass through information, and you're using already prepared strings on the other side. You can also minimize the number of DOM calls to a bare minimum. U is quite vocal about it. Whenever the component changes, is re-rendering the whole component, which is not the best way of doing stuff. So also you should also make it as reactive as humanly possible. And actually, Leptos framework does exactly that. So let's take as an example how the Leptos version of the same app would look like. Quite similar, isn't it? Differences. In here, you're not having states. You're having something called signals, and you're always passing a context around. It's pretty much most of it's just syntax. However, signals are significantly different. What it actually does is, with the view macro, whenever something is being changed over there, Leptos knows how little it can change when it comes for the DOM structure to reflect the changes from a signal. That means that whenever there will be a change of this value, only a span will be changed over there, not the whole component. Also, it implements all the other things that we've been talking about, which is it implements how you can cache all the strings as significantly as you can, and how you can minimize the DOM calls, right? So it simplifies a lot. So does it make any sense? How faster can it be with all the restrictions that we already have? Remembering that still Leptos, as is single-threaded. So let's take the same lists of actions from the same library of benchmarking library. Let's add the select row as the last part as well. And let's take the three libraries right now, React, Vue, and Leptos. So here are the numbers. It's a significant change, only because we've minimized the number of strings being copied around from one side to the other. Significant enough that if you look, for example, at numbers in, let me look at it closely. Yeah, all of them are well faster than it was before. Leptos is definitely better than both of them. But how that compare to the vanilla JS, which is the fastest possible way of building the same stuff? Quite well, actually. It's so fast that in some situations, like creating a lot of rows in an instant, it's faster than vanilla.js, because vanilla.js will still have to iterate, and simple iteration will be faster in our Rust than it will be in JavaScript. So with Leptos, it's actually even better. So with no further ado, why shouldn't we simply use Leptos library, framework, whatever, with everything we do for websites? Well, for starters, it's being done by a single person, Greg Johnson, which is a great, brilliant guy, but he's still a single guy doing this. And he's still rewriting a lot of APIs around the foundations of the whole framework that he's doing. And also, it's not enough. So we've been developing a couple of websites using Leptos, and we needed to simply go back to Vue implementations instead, because Leptos was unstable enough to simply scare us off. Also, both of these are still lacking a lot of functions, because what could you do better? First of all, you should even check if you can do less updates to the DOM, even less than it was in a reactive, quote-unquote reactive version that you've got in Leptos. You should also consider something, which is building your own CSS mechanism that you can simply minify and create the same structure of caching system on the JavaScript side for the names of all classes or IDs that you're generating automatically from your project. That would be also a good idea. You should also make it real reactive, meaning that you should be using multi-threaded mechanism that you've got in a browser, which is called web workers. They are not really implemented by neither of the libraries. They do support them. You can use them. You can create your own web worker and do something with it, but the rendering mechanisms are not using it. And React system actually does. React is so slow, mainly because it's a huge library, but they have really a good idea with the multi-threaded web working reactive updates of a DOM. Also, what it would still missing is a full toolchain for the development. You're using trunk that is not even giving you the debugging mechanism. You don't have a real CSS generation or minification written in Rust or anything that could be very fast in usage with the whole system. And also you don't have templates or components that you can reuse across like you have with Angular or React. You have a lot of simple components over there you can reuse anywhere. Why can't we? Why everybody's focusing on other stuff? And last but not least, we can fix the browsers, right? Because, well, we can define our own standards extensions proposals to actually destroy the bridge, to make calls to DOM, to the network or whatsoever native for WebAssembly. It's possible. It's not that difficult. We can even make our own Chromium pull request with that. It's not that difficult, really. So that's our plan. We've conceived Rudder Foundation. This is a child of two companies right now, Darkpool 1 and Tianite. But the fact is that we're open to everyone, and Rudder is not only around WebAssembly code. It does a lot of other things, but the stuff that I want to tell you now is one big framework over there that we've called Key. What Key is exactly what I already said. First of all, delivers its own CSS generation toolchain. Delivers standard components to be used in whatever React versions you've seen before, Angular ones. It's multi-threaded and uses background DOM refreshes using web workers, and delivers own debug toolchain that connects to Chrome browsers and probably maybe other browsers in the future. It's prepared for DOM manipulations, and it's being delivered, that will be delivered to the browsers eventually, we suppose. And it's open source, obviously. We already have a plan how this will be looking like. So first will be the DOM management part that will be probably released on the 4th quarter of this year. CSS generation tool will follow. Debugging toolchain will be next, and the standard components last. You don't see dates over there because part of this talk is also me calling to arms. It's an open source project and everybody's invited to join. We want to make WebAssembly actually a standard of web development, and we know it's possible. We know enough, especially that people already involved in this is people that have been doing browsers and developed Angular framework before. We know what we're doing. You can find us there. You can subscribe for news. And if you want to join us, email me at bassett@rudder.foundation. We're very open for everyone to help us out and make this quicker. Thank you. Q&A? Questions?
Yeah, I actually have a question, which I wanted not to ask, but I see you are very seriously involved in this WebAssembly thing. And my question is basically why? I mean,
Why?
Sorry. Now let me explain. So I am strongly advocating for WASM in general.
Mm-hmm.
I am working in a company which has WASM in the name.
Yeah, seen that. Yeah.
Okay, so, but what I remember wasn't at the very beginning, the idea was, as you told, maybe enable some games in browser, computation in browser, and this was the initial idea.
Mm-hmm.
And now I see this, that the focus is kind of shifted to web development.
Mm-hmm.
So to create web applications purely in maybe Rust or something like this.
Mm-hmm.
And from like individual contributor developer point of view, I find it great because now Rust Dev can provide you the website, but when I take a look from the business perspective, I see that it's at the end of the day easier to find a React developer than Rust developer knowing Reptos or something. And my question here is why this focus change? And if it is
Answer is not that simple, but I'll try. First of all, looking at the history, the problem was that all companies want to have just one kind of developers. That's why we have Node.js, which is, however you'll call it, but this is the most stupid idea I've ever heard of, right? It's a single-threaded mechanism that you have on your back end with a language that is pretty much, well, too simple. Well, but people are using it because they're having the same people doing the same stuff on the front and the back end. You want to change the game the other way, right? If you have brilliant people that are already doing the back end part, you want them to be able to do stuff on the front end as well. That's first. Second of all of these apps that WebAssembly delivers always needs to have, for example, internet connectivity that goes through the bridge. It has to, which is stupid. Also, why WebAssembly right now is being used as like Docker right now. Docker is even starting to use WebAssembly right now. You have WASI, so there's system interfaces. Why don't you have it in browser? And last but not least, the biggest problem that JavaScript solutions have, React including, is that people that are writing them, well, with Rust, you have a static compilation and checking of everything that you've done so far, which is, I think, the biggest advantage of everything that you're doing right now with Rust. That's why a lot of people are actually going into this. You can omit a lot of obstacles and future errors just because you're using the right frameworks. JavaScript is very simple to, how to say it? The best word probably is to abuse. I mean, you can do pretty much everything over there, including destroying your whole company with it. I think there was a talk that Airbnb did back in the day, that they were using a pure JavaScript back before, and if they would be just using a stronger types with TypeScript, they would omit 78% of all the problems they ever had. So that goes with all the rest of it. Also, JavaScript and most of these environments are single-threaded, and it's easier to keep them in line using languages as Rust to go through threads than in JavaScript. Does that answer your question?
Yeah, I mean, in general, I wish you the best. I keep you to talk because I like it. I'm just.
Yeah.
You know.
So last but not least, security. Security is quite important whenever you're going into regions that you don't want to share. I know that quite often it's just security by obscurity, but if you're delivering a binary, it's not that simple to check out how the website works than it would be with a JavaScript that you can decompile. Just saying.
No, about security, I'm really interested in that, but my idea is that something is about security, it won't happen on client side.
That is true.
So that's why security doesn't convince me this much. The other arguments far more.
Also, last but not least, communication-wise, when you're going to the internet connectivity, we're doing it a lot. And with JavaScript, all the connectivity is always text. Even if you're saying it's not a text, it's still a text. That's why we have something called REST communication. That's why we have JSON, for crying out loud, which is, sorry for my French, but it's shit, right? You have a lot of interesting ways of communicating, like gRPCs, right? You have a binary, very small packages that can fly around, but you're using language that can't really operate over them. And if you have everything in common, you have your common libraries that you can use on back and front end. You can make it all binary. You can just throw it stuff around. You just make it faster, simply.
Yeah, I mean, thank you for the answer. Okay.
Any more questions?
We have pizza ordered, which should be when?
Yeah, they should be here in a few minutes, so I'll call them to make sure it'll be on time.
You still have the time. You can ask questions, and then when pizza comes, we'll have a break between talks. That's all I wanted to say. Yeah.
Okay.
So, any questions to Basil?
Okay. You can find me there. So if any more questions will arrive, feel free. Thank you.
Okay, thank you very much, Basil. Now, yeah, we will take a short break now because of pizza, which should come, and in 15 up to 20 minutes we should be back online, mostly for remote attendees. So see ya then. We are back. We should be also back online. We got some little pizza delay, but I think we can start again. Patryk Wychowaniec will give us a talk about, he would ride on a tide with his IDE. So he would explain why Emacs and Rust works on his machine. Yeah, I believe he just like Emacs makes computer slow with Rust. Patrick, are you there? Yeah, no. My joke was repetitive.
1, 2, 3, 1, 2, 3. Yeah, I'm here. 1 second, let me prepare my machine. Okay. Right. Maybe let's zoom out a bit. All right, so we'll start with a quote, which is, give me 6 hours to chop down a tree, and I will spend the first 4 sharpening the axe. I like this quote very much because I sit half my day looking at code, looking at my text editor. So it would make sense that if there are some things that annoy me or make me, slower, then I would just like to fix them. So to give some extreme comparison, I wouldn't write code in LibreOffice, say. So that's obvious. So no, I wouldn't. So the editor I'm using comes from the 80s, so it's really much older than me. It's called Emacs, and I would like to talk about it because recently, in the recent years, there's been a proliferation of distributions of Emacs. Distribution in this case being like prepackaged Emacs. So in this case, you see this name Doom Emacs. So this is the name of the Emacs variant I'm using. And what this means basically is that if you download Doom Emacs, you start with fully fledged IDE. So you can code Rust in it, you can code PHP within it, whatever. And you get all of the usual, VS Code, C-Line kind of stuff, which is some debugging experience, so, auto-completion and stuff. And, to start, I will open some random project I have on my machine. So we will not go through the code. I'm just opening it so you can see, how it looks like, how the program that I'm using each day, both in work and after work, looks like. And first of one of the most important things, at least compared to vanilla VS Code or LibreOffice experience, is that in here the editor has modes. So, for instance, normally when you write stuff, you use your words and you write some stuff. And if I want to do some action, like say undo, then instead of pressing some magical key binding such as Ctrl-Z, I change my editor's mode. So I use escape key in this case, which reminds me that I actually have installed, an application to show which keys I'm pressing. So maybe we'll see if it works. Okay, yep. 1, 2, 3. Yep, okay. So this funky sign is escape key in this case. So if I press escape key, I go back to what's called normal mode. And for instance, in this case, if I press U, it doesn't type the U key. It's action called undo. And this is very nice because this means that I can, for instance, instead of doing some magical combinations that require 2 hands and foot pedal to execute, I can just enter them in here. And for instance, to show you what I'm using each day, for instance, a command called V, which is used for selection. And then, for instance, I can press VIW to select the whole word that I've got my caret in. So let's say that I will go into the middle of this word, if I want to select this whole word, I press like V like visual, inside word, and it selects the entire word, and I can press now, for instance, X to delete it. Or a very similar combination is V, select, inside, and now braces, and you know I've got the whole expression. Or similarly, V, A, so A, I guess, resembling outside, parentheses, selects the whole text with parentheses. And in my opinion, this is way better than, you know, some Ctrl-Shift-L, K, F10 combination, because you can then pair it with other actions, such as, let's say that I wanted to swap what I've got in here with the stuff in here. So I do not know what could be the combination for that, you know, in usual IDE, but in this case, I press GX for like exchange or swap. Inside this parentheses, I've got it selected for swap. Now I press in here, and once again, the same in parentheses, and it's swapped. And the magic is that the combination, so this action is very similar for, so the swapping command is always GX, and the thing that I'm swapping, the object, can be anything. So I can similarly swap just the single word if I press GX inside word, which selects the whole word. Now go back, GX inside word, and it's nice. And this is called model editing. It's called model because, as I said, the editor has a few modes. So you can see by the caret that when the caret is like full rectangle, it's in the command mode. So in this case, if I, for instance, press J and K, they move the cursor around. And if I want to actually type something, I press E to press insert mode, and now I'm actually typing. So this is not strictly Emacs, because this is this is called actually evil package, because this simulates V inside Emacs. And let me take a look at my plan, because I prepared some stuff I would like to, where's my tab? In here, yep. Some stuff that I would like to show. Right, so another fun stuff is, for instance, let's say that I scroll a bit here, somewhere. Okay. So when I'm writing code, I usually don't use my mouse at all. So if I want to jump somewhere, I can, for instance, type the word that I want to jump into. Let's say I want to jump to something containing the word DA. So to recap, I press, I enter the search mode, press DA to search for, some part. And now the stuff that remained ungrayed out contains letters. And now I can press those letters, which is either A or S, to jump to, this place. And this is also very powerful because, for instance, I can, instead of just jumping, I can as well just, for instance, jump directly to the type of that stuff. So if I press BU, it shows all occurrences of this, word BU in my buffer. I can now jump directly to the, for instance, type of the variable called buffer. So this is, very fast. And as before, I do not need to remember any, Control-Shift pedal and do the Spock sign with hand combination to do it. And since we're talking about Rust code, then maybe let's talk about the usual IDE experience of, writing Rust code. So why would you like to use Emacs? Because I know that for some people, probably for almost everybody, because that's also how I started, this feels like it's a very old tool that it's not that good for, writing text in it, and probably you can't even rename stuff, or it's difficult to set up. And with this talk, I wanted to show you that, maybe kind of prove to you that it's actually very simple, and it gives you everything a typical VS Code or CLion installation would do as well. And for some context, I actually transitioned from CLion and from VS Code to Emacs, so this is not just, vain words. I do have comparison. And out of the typical IDE experience, you might want to, I don't know, rename some stuff. So sure enough, this also works. Renaming works by using a command called space code rename, so space CR. On the bottom, you see that it entered the renaming mode. I can change label to, I don't know, 4. And it actually changes all of the occurrences. And it's not text substitution, so it's not as dumb as text replacement. It actually uses REST analyzer underneath, so you get all of the typical, basically the same experience as you would do in VS Code. And this also includes changes like, I don't know, maybe struct fields, or maybe even some functions that require renaming other files. So all of this stuff works in here as well. Then out of the cool stuff is that if I wanted to search, let's say for all occurrences of the, I don't know, let's say I want to find out where this data field is read. So this also works here. I can in this case press G and A, and I immediately see all of the places where this is read, and I can filter them out even more. So I can, for instance, type mute to find all of the mutable references to this field across the whole project. Similarly, when I'm inside, let's say I'm in here and I want to jump into this data size, I can press G, which is like reserved for like actions regarding the word I'm on. I press G and D, and I'm right here. Can go back. I can also search for stuff that is not related to REST analyzer, so I can enter like generic search mode. Let's say we search for, I don't know, pad. So this is very convenient because in Emacs everything is text. So what this means in practice is that, for instance, this searching component at the bottom, well, it's actually feels like it clutters the whole space, but that's just because I zoomed in. In reality, it's like the proportions are something like that. The great thing is that you can export this, so export the search results into a separate buffer. You can move it right here. And now I can go back to editing this file, and the search results actually stay. I can move them anywhere I want, and this comes very handy during refactoring because I can just search for some stuff, keep the search stuff somewhere on the right side, or hidden but present, and go back to them later. So this comes very handy. Out of other features that come handy, for instance, let's say zoom in. So let's say that I select the whole functions. This whole function, so I select V for selection. Around function, I have the whole function selected. I can now zoom in into this whole function, and all I see in here, so this is the whole file now, is just the zoomed in part, and this is not a copy. So if I go in here and modify something and go back, the changes are actually reflected in here. So this comes handy if you if you want to, like, I don't know, focus. Oh, sorry, this is a bit zoomed out. Maybe like this. This comes handy if you want to focus on one part of code, on one part of JSON file, because you can just focus on a single object. What's more? We also have replacement. So typically, if you use VS Code, if I recall correctly, the way you do mass replacement, so replacing text across the entire project, is that you open some, I think it looks like this, so you have some search, and then you have replace to, and then you have some button to actually, I don't know, apply the change, something like that. This is how, at least I recall it. And it's way better, in my opinion, at least in Emacs, because all of those actions, so searching, replacing and stuff, they are separate. So to give concrete example, let's say that I will look for all occurrences across the whole project of the word camera. So I've got lots of them. And by the way, what I write in here, it actually executes rip grep. So for instance, you can narrow it down to just TOML files. But by default, it searches everything. So as before, I can export those search results into a buffer. I can make this buffer writable. And for instance, replace all of those with camera with K, which I actually accidentally broken up. So let me try again. So I have camera, let's say with K. And those changes are still not applied, so I can still, preview what I want to apply. And what's more, because this is just a text buffer, like all of those, I can say run a regex in here. I can do all of the stuff I do usually with text, and then I press ZZ to apply the changes, and it's done. Or I can press DQ to roll back and not apply anything whatsoever. And this is very handy because it's much more versatile than just flat back search and replace, even regex search and replace. Because first of all, I see all of the occurrences in here. I see the files, the lines, and in this buffer, I can use all of the stuff, to work with text I use in other buffers. So I can, jump to words or use some further filtering, and stuff just works. So this is one of the power, power features that I haven't found anywhere else. Out of the other cool stuff, for instance, what comes handy, especially in Rust, is jumping directly to the librs or maybe to cargo TOML, which is also automated in here. So the action starts with space M. Space M in this case contains all of the commands specific to the code that is open in this buffer. So for instance, I have space M crate check, which checks the whole crate. I have space M workspace, so space MW for workspace check, which checks the whole workspace. Or space M O for open, and I have cargo lib main, so let's say I want to open nearby cargo TOML. Out of other stuff, you might notice that usually when you have an IDE, you have the file list or file tree on the left-hand side, and that's what I started with, and this is what is actually installed by default into Emacs. So you have this file tree on the left side. I actually don't use it because I find that it actually just clutters space, because I frequently have 2 or 3 files opened, on some funky configurations, I don't know, some random files. And then, this tree just takes space, and this tree doesn't convey many information. So for instance, if I wanted to jump to a file, I press space. I have all of the files of this project present in here, and I can just find, I don't know, some indirect librs, let's say, in here. Maybe I can close all of them. So space, it lists all of the files, and what's also handy is space, comma, which lists all of the files that I have already opened in here, so files that I have opened right now. So for instance, if I would like to jump to a file called buffer, I have lots of them, but if I know that I have already been there, I can press space, comma, write buffer, and this lists only the 2 files that I have actually visited and that are present. Okay, yep, so Emacs with Rust, I've already shown you jumping to stuff. So, for instance, G as a shortcut for goto. So GT, go to type, it jumps to the type of the variable. GD, like go to definition, jumps to the definition. And GA, like usages, I guess, jumps to the usages. So this is, as before, very handy because it's, I think, much more easier to understand and prepare for yourself. Because if you want to create some new combination, and I think, for instance, GA is something that is named differently by default. I think it's G and uppercase D. And I will just rename it to GA because it's easier to type. Other funky stuff, I have terminal. I have under, well, I have macOS, so I have special command, which comes handy. I have command S, which opens the terminal at the bottom or closes it. So this is also handy because I can just, I don't know, work in a project. I want to run cargo test or anywhere. I run it, close the terminal, it's working in the background. I do some stuff and go back to it. Oh, never mind, it fails. Okay, so as for editing, text, I think this would be most of it, but some of you might have heard that Emacs is like operating system, so there's a lot of it in here. Well, I think the full quote is that it's like an operating system with, it's just missing, text editor, which I think is not true anymore for 21st century, because I think the editing experience in here is phenomenal. And that is to say that I wasn't also really so sure at first. I had like 3 approaches to trying out Emacs. I've been using it for like a year and a half now, and I'm much more happy than I was with VS Code, so that's why I'm also presenting it here. But it's not only because the text editing is great, it's also due to some other tools or plugins you can install in Emacs, and one of those is, for all of you that use Git people, there is a tool called Magit. Well, it's not a tool as much as a plugin to Emacs, and Magit is a pretty GUI for Git. So I have Magit under space GG. So, well, maybe for comparison, if you wanted to see what changes you've made, usually you would do something like git status, and then I see what I've modified. Magit goes 50 steps ahead, and it presents you with the whole overview of the repository we have at hand. So I have my newest commit. If I haven't pushed my commit just yet, this is the newest commit from the remote repository. So in this context, this would be the older commit. I can go through changes, and I can decide to commit them or not on a per diff basis. So let's say that I modified this README in 2 places, and actually at this point I will probably just disable the key overlay. Let's say that I wanted to change it to Lysa. No, it's like this. If now I go back to Magit, this file contains 2 separate diffs. So this is the first diff, this is the second diff, and I can decide which one I want to push. So I'll stage, or I can stage the whole file, or even I can stage a particular change. So I'm not limited to this whole diff. It's not everything or nothing. I can stage just these 2 lines, let's say. And this is something you either cannot do with Git, or I haven't been able to, at least very easily. Mostly because well, first of all, this is also just a text buffer, so everything you would use to modify text also works in here, like I don't know, some searching and whatnot. So you don't have to learn any new syntax to operate this tool. And what's great, I wanted to say that it comes very handy for refactoring, because I frequently find myself implementing some new feature, doing 50 more refactorings on the way, and then I'm left with this huge list of unstaged changes. And if not for Magit, then I would probably either not do the refactoring, because it would be difficult to separate it from the actual new feature or some bug fix. But with this tool, if I had some changes in one file and half of those changes refers to new feature, half of those changes refer to refactoring, I can just separate them. So let's say this would be refactoring. Let's say this would be refactoring. So I have those changes staged. I create a commit with just those changes, where I can, as before, preview changes to make sure I'm committing only what I need to do. Commit created. And I'm left with the rest of the changes. So this would be either the feature I wanted to implement or some other stuff. And Magit is also great because, well, let me collapse all of the changes at this point. Because this is very much what you see is what you get kind of a tool, so you can click everywhere in here. So for instance, this says change stashes. I can go to any one of the stashes from before, instantly get div, and in this div, I can, for instance, decide that I want to bring this change back into my index, but I don't want to, bring back the whole stash. I'm just interested in this single change. So I go here or, here anywhere. I press A, short for apply. And well, in this case, this change doesn't apply because this is older stash. But in general, if the code was still, similar, this change I've selected, only this single change would be applied back to my tree, which also comes handy for refactoring or, just sketching out ideas which you can quickly stash and go back to later. And if not for Magit, as before, I would have probably not done it because this would be either awkward with Git or just plain impossible. So this is really a game changer when it comes to working with code. And for if you're still not sold, one more killer feature I'm using basically daily is that I have some changes made, but I want to apply them to an already existing commit. So let's say that this is the list of the commits, and let's say that what I've actually implemented right now is still some part of refactoring from the past. So usually what you would do in a Git is you would create a commit, then perform an interactive rebase and move that commit or fix up it to the past. While in Magit, all I do is that I stage the changes, press C for commit, and this shows all of the actions that I can, this committing can do. So CC is just regular commit. So this is, let's say, how I've created this one. But CF, so instant fix up, allows me to select a commit to which I want to, insert those changes. So this is rebase automatically in the background. So this is very fast, and as before, it comes very handy for refactorings because sometimes you either forget or you later only realize that some change should have been committed in the past. And this really allows you to keep the history clean. So out of other funky stuff, so this is a small one that comes handy. If I write, some equation, I can select it, press equal sign, and get the result. Also comes handy from time to time. And there's also very great, there's also great undo functionality. So usually when you have undo or redo in typical IDE, it works linearly. So you can either undo, and then if you make a change, you don't have redo anymore. You cannot, go back because where would you have gone back? Well, in Emacs, the undo is actually kind of like a git. So if I, edit some code, I can enter the undo mode. Let me see if I can make it more readable. Maybe I will need to zoom out a bit. I can enter the undo mode. Oh no, it's just very wide because I've been practicing on this file as well. So you can see on the left side is the version of the file that I'm right now. And this -30M, you might not see it from here, but it just says the timestamp for when this file was modified. So I can go back to any of the change from the past. And for instance, if I go back to past in here and start modifying, I can press undo and still go back to any other of the versions that I have. So this might feel complicated, especially if you have lots of edits, but this becomes very intuitive in time because you just realize that you create another tree. If you do undo, then you make a change, and this creates a separate branch in here. And this branching allows you to go back to all of the versions of this file from the past. And this doesn't require explicit git commit because, well, it doesn't even require a git repository because it works purely on the Emacs's files. So this comes handy. And there's also one of the killer features, well, saying killer feature a lot these days. One of the nice features is, for instance, also working on files. So I can press space and then J, like jump, to jump to the directory in which is the file that I was looking at. And in here, I can also edit this, let's say, modifiable mode. So similarly as with grabbing text and then modifying what I see and saving changes, same principle works in here. I see some files, and let's say I wanted to rename them to Bubble Duffet. So I just modify it in here. I press ZZ to perform the changes, and it's done. This is way better than rename, because as before, if I had millions of files to rename and they all followed some regex, I can just literally execute a regex in here that would rename all of the files and then click apply, and they would all get renamed. When I was trying to do something like that 2.5 years ago, I think for some task I had, some debugging, before I was using Emacs, I had to search for a dedicated mass rename tool on on GitHub, for which you will find some, but all of those tools are strictly related to, say, mass modifying files or, mass renaming them, mass search and replace. And you don't have this curated experience of using all of the key bindings you already know inside the text editor. Okay, so let me go back to here and undo all of the changes. So literally I just go in here, press X, like delete. It suggests if I want to undo, discard, and I'm back. So this is like git reset or git checkout. Also, what's very nice is that you can connect to servers or even to go inside a Docker container right in here. So I can press XF, which is used for finding files, anywhere in my file system. I can say SSH, and let's, for instance, open, the server. And voila, I'm logged in on a server. I can now open second instance of it. I can, let's say, go to different directory. I can copy files between those. And what's nice is that if you have two windows, so two directory window opens right to one another, if you press rename, it automatically suggests you to move the file to the second instance. So you don't have to retype this path. Or you can even copy file back to the file system if you just go back to, in this case, so the left hand side is the server, right hand side is my machine. If I wanted to copy file from one to another, I just go, in this case, for instance, in here, I press C for copy. It automatically suggests my machine, and I would press enter, but I'm using ZSH also locally, so I would not like to overwrite it. But this would just copy the file from remote machine into my machine. Or the other way around, I can go in here, press C, it suggests, in this case, the machine. I can press enter and copy the file there. Similarly, with this SSH, so instead of SSH protocol, I can also use Docker protocol. I have some Docker machine opened, and voila, I'm basically logged into a Docker container right now. And I can do all of the same stuff I've done before. So I can, let's say, copy this Erlang cookie into my SSH machine. Or in this case, if I change this second instance to be my local machine, I can copy this from Docker container to my local machine. So this is way more easier than Docker CP, because, well, it's more versatile because you can copy from Docker to Docker, from Docker to SSH machine, from SSH machine through 50 other machines to whatever you want it to. And you still don't have to use mouse in here. So I really don't like touchpads, so this is why I'm actually using Emacs. Never mind. Out of the other stuff, there is also kind of terminal emulator. So if you have regular bash stuff, you can log into a machine, and then you have, when you log into this machine, you have some of this machine's functionality in here. And there is a terminal emulator called Warp that one of its features that they advertise is that if you log in to a machine, if you do SSH, you still have the local shell experience on that machine. And Emacs has supported this already for almost always. So this is called eShell. So this is basically like a shell, but instead of running commands, you actually run some Lisp code that simulates a command. And the difference is that you don't need to have ls installed on, well, in this case, my Docker container to actually execute this command. I can also do login into, let's say, this SSH machine by just doing cd. It suggests already name. Okay. I can do cp from, I don't know, let's copy some tmax config into my local machine into temporary file. No, why do you suggest like this maybe? And this is basically, I think this cp working to copy files between machines even more than warp can do. But this is very handy because you can, you don't have to worry about AirSyncing stuff or installing AirSync or remote machine to copy some files, or you can just use cp to copy files locally on your machine, between machines, inside Docker container, through root, everywhere. It just works. And I'm pretty amazed that it's not talked upon more widely, because this is really, really convenient. And this all basically just works. So this is nice. And maybe to kind of wrap up where I'm going with this, because probably should have started with this, but I do not really want this to be much of a please convert to Emacs kind of a talk. I just wanted to share, some cool functionalities that you might not know that even your current editor can do when you install some plugins. Some stuff that could be just convenient, when you use text, when you edit text or work on files daily. And all of this stuff. So like, so quick jumps to some files, to some, words and stuff. It's not as much to save you 1 millisecond a day. It's more of an mental effort kind of a thing. So for instance, if there is something difficult to do, I might postpone it or do it later. So like, I don't know, I could copy some configuration between machines, or solve some bug easily this way. But if it's a difficult thing to do, so it would, I don't know, require installing some extra stuff, I would have probably not done it or do it later. While if it's easy to do, I will just do it right now. So what I'm going towards, I guess, is that if you have some things that are frustrating to do in your text editor or in your daily workflow, it might be nice to enhance your code editor to create even your own plugin for it. And this is why I'm using Emacs, because some of the stuff I showed you today is not actually, it's not in the built-in. It's not built-in of Emacs. It required some code. And while I love using Emacs, is that it's very easily hackable. For instance, I will show you some quick instance of the functionality that I did not have in Emacs. I coded it and now I have it. Let me open my Emacs configuration. Maybe this one. So for instance, I have a command that jumps to the nearby cargo toml. So I guess this would be actually, okay, let's say nearby main arrays, because that's the easiest I have on hand. This is not a built-in, I had to code it manually, but it all boils down to basically defining a function, telling it to find the nearest cargo toml, and from there, find the nearest main arrays file. You don't have to actually understand most of it, and to be fair, I've been still eLisp, so this language is pretty difficult to grasp, especially if you're not used to Lisp-like languages with lots of parentheses. But it's actually very, very quick to iterate upon, because if let's say if you're using Emacs and you wanted to have this functionality, I could just send you this function on Slack. So all you would do is that you would open a new buffer. Let's say that I send you this code. And then what is only missing is the key map. So, mapping this function into some key, which in this case is, I think, this one. So this defines a key map where this is space, O, and this would be only the main rs. And you could select it, tell it to, tell it Emacs to execute those two functions, and that's it. That's voila. You don't have to. It would just be working, and this is much more difficult in IDEs such as those of IntelliJ's, where you have to compile actually the plugins because they're in Java or Kotlin. Not sure what they have right now. But at Emacs, I would just send you this snippet, you execute it, and you have this functionality. I mean, obviously, if you wanted to, for this to survive restart of your Emacs, you would have to store it into some configuration file. But for quick check-in of stuff, quick iterations, this is very handy because you just literally execute it, then execute this one, and that's it. It works. It's in your IDE. And I've got lots of those functionalities in here. For instance, this evaluation, so stuff like that. It's also not built in. I have it bound somewhere in here. Oh. Yeah, so actually that's this one. So this is the single line of code that allows me to evaluate the expression I have at hand. So I map something. This corresponds to the state when I have some selected word. So when I have some word selected and I press this key, I just call some function from Emacs that knows how to evaluate stuff. So similarly, toggling line numbers. I usually don't use line numbers, but it's when I say do pair programming or I stream, I sometimes enable them because it's easier to find, to have some common point of reference. And what I'm aiming towards is that I love Emacs because it's easy to hack, really, and it feels like it's either, when you look at it right now, it feels like it's very weird. So let's say, what's this? Why it's exclamation mark in here? Why PT? What's that? But it's actually very easy to get into. For almost everything, you have pretty nice documentation. So for instance, if I go back to this after that I had in here, if I want to know what this go to chart does, I press Shift K, which stands for help. And there it is. I have help. I know what it does. So why Emacs? Because I like to make my life easier, and sometimes it takes. Sometimes you have job that takes 15 minutes to do, and you take 1 day to automate it. So then it's not worth it, obviously. But sometimes there are just small things in your editor that can feel like they are, awkward or maybe set in stone in the case of compiled IDEs they cannot modify. And I love Emacs because there is almost nothing that is set in stone in here. You can modify everything everywhere all at once, and it's very nice. And as before, now I realize that this talk kind of feels like please transition to Emacs, but I would like for it more to resemble some cool stuff that I can do in here that you might be able to do as well if you search for plugins to VS Code or IntelliJ, because there's millions of plugins there. And yeah, I guess this would be it. This is my 1.5 years of using Emacs and showing some cool stuff that helps me basically each day. Thank you. Yeah, I guess this would be time for Q&A.
Yeah, I obviously have a queue. Okay, so I pretty much like your analogy of Control-Shift pedal F11, mostly because now I have my fully functional 88 keys MIDI keyboard, so I finally can map all my Vim commands. which is basically the same for Emacs. You switch your Control Shift pedal F11 to write a poem to do a thing. I mean, I am Vim user, so basically the same thing. But I recently went back to actually use file format binding to simplify, because what you shown at some point is, yeah, you can have your search hide lines and then pick your search and execute an action. My practice is that what I would do more often would just quickly type what I am looking for, then click N couple times and then execute the proper command, mostly because it's easier to me to see what happens. And now my question is, in practice, in day-to-day work, how much you actually write poems and how much you actually fall back to very simple commands, like doing one by one, because your thought process is faster than remembering commands.
Oh, so actually at this point I execute most of the commands, I know most of them by heart, so I don't really think about what's the difference between VA or VE or X or CD, XY, BLM. I see the code, I understand the change I need to make, so let's say remove parentheses or stuff, and I just intuitively know what to do. So this is, like I said, nice because it kind of feels like you're writing a poem with 5 modifier, not modifier keys, 5 chars characters to enter and make the editor understand you. But this is actually very fast. So for instance, to do a quick comparison, if I go back to my Rust project, I have to open some Rust file. If I wanted to run cargo check workspace, I press space and WC. Well, it says that I did have some files modified, but it's actually very fast. So like this, and I have cargo check to run. Similarly for test, so space M, workspace tests. If there are some errors, I can just open them on the right hand side, and this feels like a lot to do, but it's very after you do it, I don't know, for like a year, it's very, very fast, and you don't actually think about what you need to press. You just do it.
I have a question. What is your startup time of this Emacs? Because when you started the presentation, it was already running.
I guess I can show it. So I can close it.
Please close also the Emacs daemon.
I'm not using daemon, so that's
don't use?
I don't use.
Okay.
So the startup is like 5 seconds, I guess. Well, it says second and 80, but it felt like 4 seconds at least. But I don't actually mind it because I usually just, so we can check it once again, I usually just open it when I'm starting the day, or it's even running for a few weeks straight. I don't really close it. So the startup type for me could be even 10 seconds. I couldn't care. But if you frequently close Emacs, there's also you can also optimize Udemy or your Emacs installation, whatever Emacs variant you're using, to be faster. And this reminds me, there is one plugin that I'm using in Doom, in Emacs, that I know that all other plugins also have. And to quickly showcase it, because it will be just a minute, let me open something. What this plugin does is that, well, maybe I will zoom in. I have some web page open. What this plugin does is that it transforms maybe sends the current text area into my Emacs instance. It's called Atomic Chrome, and I think it works also for VS Code. So I have opened some text area. This text area contains markdown code, but it's not actually formatted because this is just pure GitHub. But if I send it to Emacs, so I have this plugin is in here called Ghost Text. It's opened in here with actual formatting and stuff. I can modify it. If not, I can then send the changes back to the browser. So this is very handy for when I'm doing, say, code reviews on a GitLab and I want to suggest some code to somebody, or I'm just writing a longer comment. I usually don't write it in here. I just open it, go back to Emacs, write some whatever with highlighting and stuff, and then I send the changes back to the browser. So I mention it because I know that this plugin Ghost Text or maybe Atomic Chrome when it comes to Emacs also works for other IDEs, and this is, I wasn't aware that you can do it, and now that I am aware, it's one of those plugins I cannot live without, so this was by the way. But yeah, but startup time 5 seconds.
About things you cannot live without. You are talking about Magit. Really, check out lazy Git. I mean, if you are using Emacs, Magit is okay. But if you have no Emacs, you still need a proper Git tool. Learn lazy Git, which is not, you know, IDE related. There's a question.
Yep.
Yes, I have a question. Can you simplify equations with your mapper?
Yeah, so
X plus x to x?
so I think this this simple substitution, it doesn't actually solve equations, but that's only because the function that I've bound to, you know, this key is not supposed to do that. But overall, in here, if you open the the Emacs calculator, I think it is able to solve equations. Let's say 2.x equals 10. There was some, no, I mean, obviously it's kind of a solution. There was something in here. I'm not using the Emacs calculator that much, but I was playing with it, and it's surprisingly also versatile. It's not as great as, I don't know, Wolfram Alpha, but it's able to actually solve lots of equations. So if you open some magic mode in here, you can write stuff such as, I don't know, something like that. And you can tell it to solve for, oh, maybe it's what, oh, solve for, okay, so maybe like this. So maybe if I write 10x equals 25, and then press solve for x, oh, yeah, so this was this one. And I think it was pretty versatile, so even stuff like, I can press solve for x. I cannot verify this is correct unless some of you can quickly compute this, but this actually works pretty nice. It supports matrices even, you know, exponential equations, imaginary numbers. So this is kind of unbelievably intricate, because you would feel like it's just, you know, some basic algebra, but actually underneath lots of tools built in Emacs, be it Magit, well, built-in is too much said for Magit, but tools that you can use with Emacs, they are surprisingly complex and intricate. And this includes this calculator, which is which I don't actually use that much, so I cannot, you know, say anything about except for those simple equations or, you know, solving for variables. Yeah.
What about highlight syntax for big files? For example, for some GPX files, XML files, did you ever have to shut down because highlight syntax for big XML files?
Yes, I do have a specific example even. Well, I think there's no point in showing it because it will just hang, but I can tell you what's going on. I have a Nix file that weighs like a megabyte or so, which is like kind of functional like language. And when I try to open it, Emacs freezes for like 4 or 5 straight minutes trying to, you know, either, I'm not really sure what it's doing, but it's frozen. And after those 5 minutes, the file is working all right. But for bigger files, it can happen that it hangs. Fortunately, when you try to actually open a big text file, say like 500 megabytes, which I don't have at hand, I think. Nope, no big files in here. But if you try to open a big file, which is file above some limit, I think 16 megabytes, it asks you if you want to open it with highlighting, in which case you will have to be patient, or in a fast, what's called fundamental mode, and then it opens it just like that without any problems. But to be sure, you know, like day-to-day Rust code, say under 1 megabyte, with Rust code I really didn't have any problems even with bigger files, so it might be something Nix specific in that case. But you know, in my daily job I never had to shut down Emacs because it target resources or anything. Mm-hmm.
Maybe I missed something, but have you told us how have you learned all that stuff? You know, Vim comes with Vim Tutor,
Mm-hmm.
IntelliJ product, the JetBrains product also comes with tutorial projects.
Mm-hmm.
So the most basic features you can explain on the demos,
Mm-hmm.
hands-on
Mm-hmm.
demos, and how about that?
Yeah, so as I said, there is a proliferation of Emacs distros right now, which also means that there is proliferation of various tutorials as well. If I look for Doom Emacs, I can even look for Doom Emacs YouTube because I think I will stumble upon this channel. I think this was the channel. Well, this is an ad, but I think this was. I think this series was the one that I started with. It goes through, you know, the basics with the vanilla Doom Emacs setup, and it teaches you, you know, everything. So, you know, you start with this, and you think to yourself, well, actually, what to do now? You know, how to clone something, how to open a file, because you do have so many in here. But if you don't know what you're aiming to do, you will not find your way around it. So it's not as much intuitive as maybe VS Code. But you can go through those series, and they are not very difficult. So it's usually like 10 minutes per episode, and it goes through Magit, through Projectile, which is used for project management, for, you know, file tree. After you go through it, it all just kind of starts to click and actually make sense, and then you can do stuff like, I don't know, open multiple projects, and I don't know, start with Git, do some fancy, you know, window shuffling, open 10 files at once, terminal, whatever. But the basic stuff you can actually learn either from YouTube videos, for which there are multiple, like tons of them right now, especially for Emacs Doom, which is, I think, one of the more popular distributions. There's also SpaceMax, which is also kind of similar. You also have, I think, maybe even a wiki somewhere in here with tutorials. Oh, yeah, quick start in this case. And it goes through, you know, all of the basic stuff. And after you get a hang of the basic stuff, discovering is very nice. So, you know, the discovery of features is great because so the basic key to do stuff in here is space. If I press space and wait, it opens a menu with hints on what I can press after space to run some action. So maybe I can zoom out a bit because it didn't show everything. Maybe like this. So I can do space to find file. It works. I can do space, I don't know, space tab to see submenu with workspaces. And after I get a hang of the, you know, basic movement, I frequently just, you know, do some combinations such as space tab, and I just see what comes, you know, from this key map in here. And this is phenomenal because it works everywhere. So if I'm in here, I can press Z, which is, you know, for some, I know, some random actions I have for the word at hand. If I press Z and wait, it also shows me, you know, what comes after Z. So I know that Z and, well, this is my custom command. So Z and semicolon in this case, it's for sorting. Z and this command also does something, and I can just run it to, you know, to see. Similarly for, I don't know, maybe M. No, M is different command. No, well, the hang on is that because all of the key maps are, you know, the Emacs has a central way of defining key maps. So it's not like every plugin does its own thing. There's a standardized system for that. And because there is this system for creating key maps, you can just press some combination, wait for this hint at the bottom to show up, and just discover. And this is basically how I discovered, you know, half of the functionalities I use, because they are frequently under some, you know, pretty random combinations. So let's say Z and apostrophe, who could think what, well, apostrophe does nothing in this case, but Z something. You will not, Z plus, let's say, you will not discover it by, maybe you'll discover it by accident, but mostly you will not know about this. But because you have those hints, you can just, you know, press Z, wait, or press space, wait, press R, wait, whatever, and see what comes comes out of that. And for the record, Space Max, so this kind of like competitive distribution to Doom Emacs, also have this space and the so this key map explainer at the bottom. So if you wanted to try, either Doom Max or Space Max are great to start. And as I said, you don't have to actually write. Well, you have to write some Lisp code to configure it, but you mostly don't have to learn Lisp to have working editor. You can just install it and play with it. And discover, yeah.
Okay, I don't see more questions, so I think we would wrap up. And after that, we would have some integration, I think, some beers or something, but give us like 5 minutes
We
to...
actually have 2 gifts to do, so following the
two
tradition,
gifts.
yeah,
Okay, sorry.
I have prepared
Good.
gifts for today. So the tradition is that we now ask one question about the first presentation and then another question about the second presentation, and we give some annexer gifts. So
Vasily, we need you.
Yep.
No, you need to ask question to your presentation because you know the presentation. We would ask something silly, you know. You should know too. Yeah, but you know. So we need some question, and basically who is first gets some slogan, which is always nice.
I'm bad at questions, generally. Let's do this. When WebAssembly has been conceived? Yep.
Okay, so the first one goes to... Yes? And Patrick, you go with your question.
1 second, let me also just give out shape, but I need to ask about size because I have 2 sizes. So maybe let's see if I can mix them up. I have L and XL. Okay, thanks. Nice. And yeah, and for my question. Not really sure what I come to the mic because I could just asked it right there, but what are the 2 names of the Emacs distros that I've talked about? Yeah, so we have Space Max.
And Tumimax.
Yeah.
You need to decide right now.
Yeah, I need to decide right now. So this was.
I already have, so you can take it.
Okay.
Okay, so I think we would wrap up the stream right now. Thank you very much, all of you, for your attendance, both you here offline and people online. And see ya after holiday break. We will announce it for sure on Slack, most probably on our another channels. I don't know, Facebook, Meetup most probably, and this kind of social media. Expect us either September or maybe October. Thank you very much for coming.